This is all the integration techniques that you need to review for the AP/BC exam. So looking at the first one, we can see that it's a partial fraction decomposition. How you're going to notice that is, first of all, that the degree of the numerator is less than the degree of the denominator. So that usually hints that it is, in fact, a partial fractions. So if the degree of the numerator is less than or equal to the degree of the denominator, and the denominator can be factored, we try partial fractions. So going through here, we would have 3x plus 1 is equal to x squared minus x minus 6, and then we're doing our decomposition. Multiply everything by the denominator. So as you take this and multiply it with the first piece, that we're going to be left with just the top. And as we multiply to the second piece, you can see the x minus 3's cancel. So you're left with x plus 2, And then lastly, as we multiply to the b piece, we're going to be left with x minus 3. And then we can pick some x's. So x equals -2 would be a great one. Plugging in to the left, we'll get -5 is equal to -5b, so that we know here b is equal to 1. And then same thing, we'll get x is equal to 3, which would give us 10 is equal to 5a, so a is equal to 2. So this problem was asking what a plus b was, so a plus b is equal to 3. All right, the second one is an improper integral. So to correctly write up an improper integral, you're going to write the limit as something approaches infinity. So here we'll have the limit as b approaches infinity from 1 to b. So just integrating this is a power rule. So we're going to go up to -2, then divide by -2. So b goes to infinity. It's going to be -x to the -2, evaluated from 1 to b. And I'm going to move that back down to the bottom and then plug in our endpoints. So -1 over b squared plus 1 over 1 squared. As b goes to infinity, this piece is going to 0. So this whole thing goes to 1. So the integral is said to converge. So later on in the year, we turn this into integral test, and this will say that this series would converge. But remember, the series sum is going to be slightly bigger than the sum of the value of the integral. All right, so the next thing we got into is integration by parts. I always say ILATE, other people say other. This is, what other people say. ILATE, it really doesn't matter either one, because you're never going to have an inverse trig function or a logarithmic in the same place, and it's just easier to say ILATE. So remember, ILATE, you're going to have your derivative side, and you're going to have your integral side. So derivative, you're going to follow the inverse trig functions, logarithmic, algebraic. Remember, algebraic things mean things like x squared, some type of polynomial. And our sine x is going to be whatever's left over. So if you want to think of the formula, it's really u dv is equal to u v minus the integral of v to u. So what they really wanted was to know what u and v were. So u is going to be what we're taking the derivative of, which is 2x, and dv will be what we're integrating, which is sine x. But let's go ahead and do this. So if I take the derivative, it goes down to 2 and then to 0. So we integrate exactly the amount of time. So the integral of sine x is minus cosine x, and the integral of minus cosine x is minus sine x. Then we alternate signs, starting with plus. Draw your diagonals, and now you're going to copy down your diagonals. So it's going to be -2x times cosine x plus 2 sine x, all of this plus c. Now, our formula is exactly the chart is exactly the formula. So if I put u over here and dv over here, if I take the derivative of u, it is du. If I take the integral of v, we get v. And then remember, we go plus, minus, then cut across with the integral. So the integral of u dv is equal to uv, which is right here, minus the integral of v du. So it's just the formula arranged in a chart that makes it a little bit easier to look at. All right, so 4, looking at it, the degree of the top is less than the degree of the bottom, so I know immediately I'm going to try partial fractions. So we're going to decompose that. Again, multiplying by the denominators. Picking some values of x. So if x is equal to 3, I know that b is going to be 1/10. If x is equal to -7, a is going to be -1/10. So we're going to have -1/10, the natural log of x plus 7, plus 1/10, the natural log of x minus 3. So if I think about combining my logs, I know it's going to either be a or b, and the one that's positive is x minus 3, so that's the one that's going to be on the top, so it's a. So 5. What we want to notice here is that things that are changing. See, this was if I take the integral of secant x, I get tangent x. So this right here, I integrated this secant x squared and I got tangent x, which means I'm probably going to take the derivative of this one and it's going to be equal to this. So the derivative, f prime, is going to be 6x squared, which means f is going to have to be 3x cubed. And by 3x cubed, I really mean 2x cubed. I can't multiply. So let's try that now. So if I have the integral of f, which is 2x cubed, times secant squared x, and we imagine doing r by parts, and we do one step. So I'm going to take 2x cubed, that's going to go on the left side. On the right side is going to be my secant squared. I'm going to take the derivative of the left side, which is going to be 6x squared, and I'm going to integrate the right side, which will give us tangent x. Then we do plus, minus, and then cut across with the integral. So let's see, f of x would be 2x cubed. All right, but whenever you see by parts, what you want to think of is that the derivative and the integral are kind of changing places. So here, it's not quite obvious, but this is an improper integral. What's happening here is right at 3, it becomes undefined on the bottom. So we really have two pieces that are improper. Once we get divergent from one of them, all of them would diverge, or both of them, because a divergent plus whatever is still going to diverge. So I'm going to take the limit, and as a approaches 3 from the left side, notice my integral is going from 1 to 4. I'm cutting it off at 3, which means I'm only approaching 3 from the left side on this piece. So 1 to a. And if I integrate that, that's going to be the natural log. And as I send a to 3, this is going to negative infinity, so this diverges. Here, again, we have a product we can't get rid of, so we'll try by parts. So you have a derivative side, and you'll have an integral side. Again, following ILATE. There's no inverse trig functions, there's no logarithmic, but there is an algebraic. We can take derivatives till that goes away. Everything else is going to be the integral. So remember, this really is a u substitution, so this is going to be 1/2 sine of 2x, and then integrating it again, minus 1/4 cosine of 2x. We alternate in the front, and then cut across. So this works out to be x over 2 sine of 2x plus 1/4 cosine of 2x plus c, which works out to be d. Okay, so first thing, because we have a proper integral, we need to make sure that it's not an improper integral. So looking at the points that we'd have issues on, which would be x equals -2 and 1, that's where the denominator is equal to 0. So this is not improper. Degree of the top is less than the degree of the bottom, so we're going to start with partial fractions. Multiplying by the denominator. Picking good values, so if x is equal to 1, we're going to get 6 is equal to 3b, so 2b or not 2b. And then if x is -2, we're going to get -12 is equal to -3a, so a is going to be 4. So integrating both of those, we're going to get 4 over x plus 2 plus 2 over x minus 1. Those are both natural logs. And then we're evaluating this from 2 to 5. I'm going to go ahead and combine those logs. So this is really the natural log of x plus 2 to the 4th times x minus 1 squared. So I'm going to evaluate this from 2 to 5. So putting in the 5, I'm going to have the natural log of 7/4 times 4 squared. And all this is minus the natural log of 4 to the 4th and 1 squared. So now I can take these and they are subtracted. So I'm going to go ahead and divide them now. So you're going to have the natural log of 7/4 times 4 squared divided by 4 to the 4th. So that's going to work out to be natural log of 7 to the 4th over 4 squared, which is b. And here we have another improper. So I'm going to do this like it was a multiple choice and not write everything out. So right here, this is by parts because I have a multiplication I can't get rid of. So ILATE tells us to pick x. We're going to be integrating e to the negative x. You do your plus minus plus. Copy down the diagonals. Then we're going to evaluate this from 1 to infinity. So this is going to be negative infinity over e to the infinity minus 1 over e to the infinity. And then minus -1 e to the -1 minus 1 e to the -1. So let's see, both of those are going to go to 0. And this is going to leave us with 2 e to the -1, which would be 2 over e, or c. All right, so now here we get to the FRQs. So the first thing it wants is f of root 3 if k is equal to 9. So first plugging in both of those things. So we're going to be integrating from 3 to root 3 of 1 over k squared plus 9. Now that's your arc tangent. So we're going to have, this is going to be 1/3 arc tangent of x over 3 evaluated from 3 to root 3. So out in front, we're going to have root 3, and we're going to have the arc tangent of root 3 over 3 minus the arc tangent of 1. I know the arc tangent of 1 is pi over 4. And the arc tangent of root 3 over 3 is pi 6th. So that works out to be negative pi over 36. Now they tell us that k is equal to -1, and we're going to find f of 4. So we're going to be integrating from 3 to 4 of 1 over x squared minus 1. So now this is no longer an arc integral. Now this is a by parts, not a by parts, a partial fraction one. And notice that it is not improper because there's no place that's causing the bottom to be equal to 0. That would happen at 1. or -1, and that's not on our interval. So going off to the side and doing our partial fractions. Multiplying by the denominator. Plugging in my x values. If x is equal to 1, we're going to get b is equal to 1/2. If x is equal to -1, we're going to get a is equal to -1/2. So this is going to be -1/2, the integral of 1 over x plus 1. And same thing. Now I can combine these. And then I'm going to evaluate from 3 to 4. So this is going to be 1/2 natural log of 4 minus 1 is 3, so 3/5 minus the natural log of 2/4, which is 1/2. And we can still combine those and get 1/2 the natural log of 6/5. Because remember, these are divided, so you'll multiply by the reciprocal. And the last way, we have k equal to 0, and we want to find the limit as x goes to 0 of f of x. Okay, so going down to there, we'd have the limit as x goes to 0, and then we're going to have the integral from 3 to infinity of 1 over x squared, so x to the -2. So when we integrate that, we're going to get -1 over x. Plugging in our values, this is supposed to be b. We're going to get the limit as b goes to infinity of -1 over b plus 1/3. As b goes to infinity, that goes to 0, so this is 1/3. So that limit does exist. And now they're giving us that g is going to be f prime, and we're trying to determine if g has a local maximum, minimum, or neither at x equals 0. So let's remember what f of x was. F of x was the integral from 3 to x of 1 over x squared plus k, where k is not equal to 0. So g is going to be f prime, which is equal to this. And we want to know if g has a local minimum, maximum, so that means we're going to have to take the derivative of g, which would be -1, chain rule 2x, x squared plus k, quantity squared. And if we're going to have a local max or min, it's going to have to be when this is equal to 0. So that means x, our critical point, would be 0. And you can see there that it does, in fact, change signs. It changes signs. Hold on. It changes from a positive to a negative over x equals 0. So since it changes from increasing to decreasing around x equals 0, x equals 0 is going to be a local maximum. Again, this will be another partial fraction decomposition. When you go through and work this, you're going to get d. Which of these integrals converge? I know for a fact this one does, because this will look like a p series because we're going from 1 to infinity. So this one definitely converges. This one, if we integrate this, and we're going to 0, this x cubed is still down at the bottom when we integrate, after we integrate it, and we're going to send that to 0, so this is going to diverge. And this was x to the -1/2, so when we integrate it, it's going to become x to the 1/2, so it's now on the top, so it doesn't matter if it's going to 0. So both 1 and 2 will converge. Again, 12 is going to be partial fraction decomposition, which is a. This one here, since the degrees are equal, long division is the first thing you're supposed to do. Now, if it was also something that's factorable on the bottom, then I would also try partial fraction decomposition. So I multiply by 1. And that's going to leave us with the integral of 1 minus 1 over x squared plus 1. So then we are going to integrate, that's going to be x, and this is the arctangent of x. This one right here is regular u sub, so if you let u equal x squared plus 1, your du is going to be 2x dx. So out in front, we're going to have a 1/2, and then we're going to be integrating. So our answer is B. Next one, this is straight up arctangent. This one right here is partial fraction decomposition because we can factor the bottom of that. So that's going to work out to be B. And this one is also going to be partial fraction decomposition again, and it's going to be C. So back to another open response. Okay, I just went ahead and wrote this one up because it's fairly long. So this is a pretty hard FRQ. It's made up. It's not one of the ones that was actually ever on a test. So they want us to find A. So looking at this, it looks like partial fraction decomposition. So I did that, but instead of using A and B, I had to use B and C because there already was an A. So I went through and did the whole partial fractions, and we get X is, A is either going to be, B was -1 and C was 2. So then we go over here and we go ahead and integrate all that, and then we plug in our endpoints, and we get down to that A is going to have to be 8, whatever was on the top. I'm sorry, it's 3, but it's whatever's on the top there. Okay, so this one, we were just breaking up things over that picture, so we want to integrate from 1 to 9. So I flipped it over and said from 1 to 9, so from 9 to 1, make that negative, and then we're just looking at the areas under those curves. On the second one, B, the easiest thing to do here is to do the u substitution. So we know it's a u substitution because inside here is x squared, outside here is x. Now we can use the fundamental theorem of calculus. Here we see that the u substitution would not work. So here we have a product we need to get rid of, so it's going to be by parts. And then here, again, it's kind of the fundamental theorem of calculus. They want us to find, they tell us g prime is equal to 5, and g of 7 is equal to 2. They want us to find g of 5. So if we integrate from 5 to 7 or 7 to 5, we'd get this, which is going to be minus that integral, and then just go through and solve that. And then kind of the same thing going on here is we have these different values. So part A, again, looking at it, it's got x times f prime, so we know that's going to be by parts. Part B, you can see that this part's going to be a u substitution. And then C, again, we have a u substitution because you can see right here that if we make sine x equal to the u, the cosine will cancel. And then D is just a really long problem and definitely harder than anything you'll ever see.